Eric Burgess here, and we've been asked to verify sine squared theta over cosine theta is equal to secant theta minus cosine theta. So let's go ahead and begin to see what we can do to this side to make it look like that side. And then once we figure it out, we can write the more formal proof. So initially we've got two directions we can really go. We can try and use some sort of a Pythagorean identity, or we can go ahead and split the sine squared into a sine times sine and scoot one of the signs off. Now, because there's a minus sign here, this gives me a sense that there was probably a Pythagorean identity used. So recall the Pythagorean identity that sine squared theta plus cosine squared theta is equal to 1. And if we subtract cosine squared theta to both sides, we're going to get just sine squared theta. And so what we'll have here is we can replace the sine squared theta with 1 minus, by the way, this is the left-hand side, 1 minus cosine squared theta over cosine theta. I'm going to go ahead and erase this to clean it up a bit. That was just to sort of show you this is the case. So with this information, we can split the fraction up into 1 under cosine theta minus cosine squared theta over cosine theta. Now these of course will simplify to 1 cosine theta, and this is secant theta. So we've discovered the steps necessary to convert it to the other side, and our hunch was right that because of this minus sign, it'd be a good idea to go down the route with the Pythagorean identities. Now, if you went down the other route, you may have still found a way over here. It would just be more complicated. And if you ever get stuck, it might be worth going back and trying out that other route. And in this case, it would have led us directly to a much easier solution. So let's go ahead and write out the formal thing here. So to write out the formal thing, we start with our beginning, which is that we have sine squared theta over cosine theta equals secant theta minus cosine theta. And then we say, well, by the Pythagorean identity, and I'll even write that right here. I like to write it in purple. So we'll write the Pythagorean ident. And this produces 1 minus cosine squared theta over cosine theta is equal to secant theta minus cosine theta. Then we say that we split the fraction up. Split fraction up. There's probably a fancier way of saying this, but this is the way I can think of saying it, so that's what we're going to use. 1 under cosine theta minus cosine squared theta over cosine theta. That's a theta, I swear. Equals secant theta. So we see we're not touching the other side. So we're using only rules that apply to one side so that we could show that this is indeed the same thing as this. Because if we started doing things to both sides, then we're assuming this equals already holds. And we can't assume that yet. We're trying to show that it holds. Alright, so after we split the fraction, it's bad math manners to do two things in one step. It really depends on the class you're in and what level is sort of expected. So we're going to do them in separate steps just to use good math manners for this. So we're going to use a reciprocal identity. Reciprocal, that's an E, identity. And this will give us a secant theta minus cosine squared theta. And the reason why is you generally want to show very simple steps that are extremely compelling, and doing more than one thing at a time can sometimes bring up questionable steps where the order may have been important. So by doing it one at a time, we make it super duper clear, like beyond the shadow of a doubt, that this has to work. And again, I think most classes would be fine with this at the same step, but we're going to do it separately. We're going to do the divide, or technically we're going to not divide, but simplify. Simplify. And this is going to give us our desired result of secant theta minus cosine theta is equal to secant theta minus cosine theta. And we say this is verified. They must be equal because this is the exact same thing. And so we have been able to show that this is indeed the case. These two things are equal, and we're good to go. If you have any questions about this, feel free to drop them down below in the comments. Subscribe and hit that bell icon for future videos. And we'll catch you in the next problem.